Okay, so we'll see how that works. Will you let me know? I'll see if it stops recording. Okay, 2.9 notes, reciprocal. Functions. They're not hard. The name sounds hard, but they're not hard. Reciprocal, if you remember back from middle school, probably reciprocal is when you flip something, right? So the reason we call it reciprocal is because if we had like the f of x equals x, for example, if we did the reciprocal function of that, then we would say, oh, well, now g of x, if we flip x, right, it's really x over 1, so if we flip it, it would be 1 over x. That's what we mean. I just want you to know that's what we mean by reciprocal functions. Okay, so just fancy word for like a fraction. We're going to do like a fraction function. Okay. Let's do, so with that example, if I had the f of x to the negative 2 power, okay, we don't like negative powers. This is equivalent to 1 over x squared. So let me explain that real quick. I'm going to go back to, this is the way I would explain it in Algebra 1. And so I don't know if this was how your teacher explained it to you, but this is how it always worked well for me. Okay, just a quick example. This is a typical Algebra 1 problem to see if you understand what a negative exponent means. So just think of negative exponents as being unhappy, just like if you're in a negative mood, right? I'm in a negative mood today, everything's going wrong, so sad. Okay, positive powers are happy. Okay. No, there's only, they're unhappy in their current location, and there's only 2 ways they can go. They can either go to the top or the bottom, numerator, denominator. Okay, so if they're unhappy, we got to move them. So the 3 is fine, the 5 is fine, the W is fine because they're happy. We're just going to move the unhappy people. So the x negative 2, we can move it to the bottom, and now it's happy. Okay, so now it's happy. And then the y to the negative 5 is sad at the bottom, so if we move it to the top, now it's happy. I don't know why it's not right. 5. Does that bring the point home? Does that make sense? Yes, it's just unhappy is in the wrong place. You just move it and then it's happy. Okay. So anyways, that's all we meant. So that's why this becomes that. Okay. So now let's get to the important stuff. Here we go. Even versus odd. Sounds very familiar, right? We've been doing that for a while. Okay. But we're going to step this up, okay, more in depth. So remember, our old even was like this, and our old odd was like that, right? The main points being here that the left arm and the right arm are both pointing up, that the left arm is pointing down and the right arm is pointing up for odd. That's the main point, okay? Now, if at any point I start going too fast, you guys make sure you stop me, ask a question, okay, if I lose you. So we're going to do an example of an even reciprocal function. Okay, so x squared. And we're going to do an example of an odd reciprocal function. Okay, so it's the power that tells you if it's even or odd. Okay, so let's sketch these. So here we go, a little bit different, okay guys? We're going to break our scheme a little bit. The even used to look like a W, like a U, like a W. Now with these, when they're a fraction, they look like this. So it doesn't look like a W anymore. Okay. But our W, yeah, bless you, but our W is still going to help us out a lot, okay? So let me show you how. If I call this arm 1, arm 2, arm 3, and arm 4, just so that me and you can communicate, which of the 4 arms are pointing to the sides? 1 and 4, right? Which of the two are pointing up or down? Okay, so 2 and 3. Now notice left and right are pointing up. Left and right are still pointing up, even though it doesn't make a W. The arms are still the same. Does that make sense? So this doesn't look the same, but it still satisfies that. So that's why it still helps us. Okay. Now here's the odd function. Again, very different than our old odd function. 2, 3. Okay, very different than our old odd function, right? But notice again, here's the important part. The arms, which two arms are the ones that are pointing up and down out of 1, 2, 3, and 4? 2 and 3, would y'all agree? 2 and 3? Okay. Notice that's the same as before. Look. Before the left one would point down, right? The left one, this is the left one, points down. The right one points up. Right one points up. So that's still true. Okay. And that helps me to remember if it goes like this or like that. Is that okay so far, guys? Yeah? Okay. So here's our goal. Okay. Let me tell you first the goal. The goal is that we can sketch these accurately. Okay. First goal with more stuff on them. And second goal, that we can extract all the info from them. Okay. Domain, range, increase, decrease, all that stuff. So we're getting closer. Okay. Let's keep going. We got that. So let's do some quick examples. Okay. So really, really rough examples of what this would look like. So for example, if I have this equation, and what if I have number 2? What if I have this one? Okay, so my goal right now is just to teach you. Let's not worry about all the movements right now. It's just a really like rough sketch. So from far away, what do these two look like? Okay, so think about that real quick. Just what do they look like? And then right now we're gonna just take a far away look, and in a second we're gonna take a really close in look. So my question to you, what I'm really asking you is this first one odd or even? And what you do is you look at the power that the x has. So odd. Okay, so that's an odd function, odd. Okay, so it's positive, so it's going to look like this. Because the left arm goes this way, the right arm goes that way. That's what I mean. Okay, now all these other numbers do other stuff, and I'm about to teach you that, but for right now. Okay, what kind of power does this example have? Even or odd? Even, okay, if you weren't sure, it's this 2. Okay, that 2 does apply to that x, so that's an even, and it's positive. So we want to know that it looks like that. You're with me? Does that make sense? Like, okay. So now we know the little preview, okay, of what it looks like. Now, what if it's negative? Okay, how would they look? So let's see. So let's do another 2 examples. So what if we had y equals negative 3, x minus 2 plus 1? Remember, right now it's just a really far away preview, and then we're going to get real close. Even or odd, guys? Odd, right? What power is the odd anyway? It's a 1, right? It's a 1, right? Power 1. 1 is odd. So odd functions look usually, right? They look like this. But we have a negative in the front. So what does the negative do? reflects it, right? It flips it, a reflection over the x. So can you picture how would that look if you flip it? Okay, and so what you do is you just flip one at a time. Just flip this one, so, and then just flip that one. Does that make sense? We're good? Any questions? Yes.
When you say negative, you're talking about the number on top.
Yes, thank you for clarifying that. Mm-hmm. It's usually on top, or they could put it off on the side right there too. Yeah. Very good. Number 2. Okay, let's try another. Y equals, let's do, so like this, I'll do that one like this. They could put the negative off like that. Let's say we had a 3 and 1 squared plus 5. Okay, think about that one, guys. So Ella, what do you think? Is this one even or odd? Odd? What number are you looking at? Even. What number are you looking at now? The 2. Yeah, that's exactly right. So here we go. Even function, okay? But then, like you said, Eduardo, negative, okay? So typical even's on the top, but if it's negative, it's flipped. Guys, how do we feel about getting the faraway preview? Does that make sense? Is that good? Okay. Question, is there anybody not clear about something? No? Okay, good. So now let's go to the more important stuff. Okay, now we're getting more serious. And I'm going to separate the video just so it's